I guess the red thing means we're recording, yeah, okay, sure. Whatever.
Okay, so furnace tune-ups. So furnaces, we kind of approach them a lot differently than we do air conditioning tune-ups. And really we should be looking at the furnaces even on air conditioning tune-ups because, you know, oftentimes, you know, we're running into about a 50%, somewhere around there. Every time we do an inspection, we find a cracked heat exchanger. So all those air conditioning tune-ups that we did all summer long, we could have been looking at the furnaces too, and then, you know, identifying those problems as well. And one of the ways to do that is to open up the top of the evaporative coil, which exposes two things. Exposes the evaporative coil, which is typically dirty, and exposes the heat exchanger. So one of the things that I like to look for at all times when I'm doing a tune-up is functionality of the system. So I can pretty much assume that the system's been designed improperly. So I'm thinking that I'm looking for inadequate return air. I'm looking for inadequate supply duct, which will restrict airflow. So one of the common indicators, by the way, is hotspots on your heat exchanger. When you see significant hotspots on your heat exchanger, that means your heat exchanger has been running too hot. So that could be for a number of reasons, but most likely it's usually because of compromised return air or compromised supply air. A lot of times customers will, you go through the house and you look at the registers and you'll see half the registers are closed upstairs. And then you have to ask the question, why do you have these closed? Oh, you know, because they're going to identify a problem that they're having. So how you make money in this business is solutions to problems, right? So whenever you see something like that, that's time to have a conversation about that. The other thing that you want to look at when looking at the return air, one of my favorite things to do is to take, if it's a furnace on stand, I like to take the return grill off if it exposes underneath, and I like to show the homeowner the filth that's under there. Because typically you're collecting 30 to 40 years worth of crap and dog hair, all kinds of weird stuff. You'll find half-eaten lunches in there from construction.
Animals. Find dead
Dead animals. You'll find rodent droppings, all this other stuff, and so you know, rodent droppings and rodent urine is one of the most significant irritants to asthmatics. So anytime you can find issues like that, obviously the homeowner is going to want to get that fixed. So I would, on tune-ups, just on those alone, I would get several $100s just to clean that box out and line it. And you can get more. That's just basically where we're starting at. But the lining insulates it, and you know, so you're not pulling in air from. So what you'll see is when you take that grill off, you're going to see studs oftentimes. And where do the studs go and stop? You know, so you know if you see studs and not drywall, that's not a sealed chamber. And even if you see drywall, it's not a sealed chamber. And what I mean by that is when you turn the furnace on or air conditioner on, it starts sucking air. It'll suck air through that grill, but it's also going to suck air through the studs. And those studs typically go up into a wall, into an attic. There'll be seams on the stand that are leaking, so it'll pull air out from your garage. It'll pull air from all kinds of places other than just the return grill. So, and that's why we want to seal them, because we don't want to be pulling pollutants from other areas of the house. Not to mention, instead of, you know, cleaning all those studs and getting all that stuff, you're only cleaning what you can see. Obviously you want to vacuum out what's there, but then when you line that with a duct liner, now it's like a whole new brand new surface area. You know, so the lid, the bottom, and the sides. Yep.
Also, sometimes when you do look in there, you'll see insulation from the walls. I've seen, sometimes they have lined it, but they lined it so that the insulation side is pointed upwards instead of the Mylar side.
Right.
So they're literally they're still pulling insulation. You're going,
Right.
oh, come on.
Fiberglass, by the way, anytime I go to an attic, it's almost like if I don't go with a mask, like I'll come out of there, I can't even talk. Like my throat just seizes up. Just because I know when I get close to fiberglass, man, that is like the most super irritant to me than anything. And I just can't talk, and I'm like coughing and it won't come out, and it like won't stop. My eyes start watering, you know, stuff like that. So those things are real irritants. So I look at you know, that return duct very closely, and then I look at the actual filter. So, and this is what, if you haven't seen that class that was presented by the guy from Geary Pacific, you want to watch that class. In fact, I've been meaning to watch it over again because it's probably one of the better classes I've seen on IAQ. And all of this leads to IAQ, actually. So what he did was he would take a baby wipe and he would wipe the inside of the return. He would wipe supply registers, and what else? A duct, inside of a duct or something like that. I'm not sure. Anyway,
If you can reach it.
Huh?
If you can reach it. If you can reach it.
Yeah. So he had 3 items anyway. He labels them on a plastic bag, and he's got the baby wipe. The baby wipe's dirty, and he labels which is which, and he leaves them with the homeowner. Because if no decision's made, you know, the other spouse is going to come home typically and see those bags and go, what's this? You know, and that'll trigger some curiosity and some questions as well. So highly recommend viewing that again. In fact, I definitely am going to view that one again. The purpose of all this is if you take out the filter and then you swipe what's past the filter and it's filthy, the filter's not really working, is it? You know, so now it's getting the system dirty, it's lowering efficiency.
Maybe in the motor blower box.
Yeah. Yeah, I
or
think
even
that's
the motor blower itself, just
Yeah.
kind of the outside of it. Because
Yeah.
now you know what's physically getting past the filter.
right.
Yeah.
So it's indicative of what's going on. This is past the filter, before the filter, and then at your supplier's register or whatever, you know. So we can see that the system's completely filthy, and most systems are reality. I like to talk to people about, you know, what's in that dust, because really it's dead skin cells, dust mites, you know, rodent feces. It's a lot of nasty stuff, and it's not necessarily your dead skin, it's somebody else's, and which is an allergen to most people, by the way. So and so it's kind of gross what goes in there. But on the more practical side, oftentimes you'll find that the filtration systems restrict a bad problem, make a bad problem worse, even with airflow. And airflow is critical because airflow ruins basically your efficiency for air conditioning, and also often causes ice overs and things like that in the air conditioning mode. But it also causes overheated heat exchangers. So airflow is kind of my go-to when I'm on a job, whether it's heating or cooling. That's pretty much what I'm going to be looking at. Obviously in the heating mode, I'm going to be looking a lot closer at the heat exchanger. That's kind of why we're there, doing we call it a safety inspection. So that's kind of why I focus a lot on the return air and the quality of the return air and the filtration system. So that when you can show the homeowner that, you know, for some of you, you can get a magnehelic. What that is a way to check your static pressure. You know, there's a couple different ways to do that, but checking static pressure on a system before and after the coil, checking your temperature before and after the furnace, after you fired the furnace. So in other words, your supply temperature, your return temperature, and see just how hot that furnace is getting, with and without the filter on. Oftentimes I'll do comparisons, so I'll pull the filter and I'll run the system without a filter just to see, or to run the furnace. If I think the return air is compromised, I'm going to run the furnace with the door off a little bit, So, and the reason I do that is because now I'm pulling air. I got plenty of air source or partially open door, so that I can mimic a properly sized return. And then I could see the changes that I'm experiencing, airflow and temperature difference and all that, and efficiency as well, because you'll notice maybe amp draw might be going down too with that as well. So, and by the way, just so you know, it's, when you're running a fan, even though it's not moving as much CFM as you want it to, you're still paying for that. You're still paying for it not to do anything, or not to do as much as it's intended to do. And what that means is the system just has to run longer. So more mileage on it. It's kind of like, driving your car with the brakes on. You can do it, but it's going to wear out your brakes. You're going to get terrible gas mileage. It's the same thing. So, so airflow is probably like the most critical thing you want to look at. There's some obvious safety issues that we need to look at as well. Renars called on a furnace the other day, had a bad heat exchanger, and we also found melted wires in the system. We wound up replacing that furnace as well. But you had a situation where flame was coming into the combustion chamber, and it was melting the wires. It was getting so hot in there. So obvious problems there. And so you're going to be inspecting the wires. You're going to be looking to make sure your limit switches work. Basically you allow your furnace to overheat. So how do we do that? How do we allow our furnace to overheat?
Disable the blower.
Disable the blower, right? So you turn your furnace on, and there's going to be a wire. It's going to say heat usually on the board. If it's older than that, you won't have a board, but you can find out which wires are going to the fan. You just disable that wire going to the fan, and then you wait to see. Okay, the furnace is supposed to come on, right? It runs through, and then what should happen?
It should turn off.
It should turn off, right? It should limit out, is what we call it. So there's a limiter switch on each and every furnace, and it limits that, so the furnace just doesn't keep going forever and ever, right? So any appliance has, gas-fired appliance has limiters on it, safety switches on it, and it's considered a significant safety that you should be checking. So a lot of times, we're going for the money shot, we're looking at heat exchangers, we're looking at run capacitors, we're looking at this, we're looking at that, but we overlook the limit switch. And trust me, there is a situation where limit switches will fail. And they'll fail in the closed position, meaning they will, what happens is, with a limit switch, there's a set of contacts and it's a bridge. And when that limit switch gets too hot, it opens up those contacts like a bridge opening up, and the current cannot flow through it anymore. Well, if it overheats and those contacts are stuck or melted together, which can happen, a lot of times they fuse together, then what's going to happen is that furnace just keeps heating and heating and heating and heating, right? And something's going to go bad really fast in a situation like that. So this is one of the more important things to do, is check your safeties. And there's usually a series of safeties but that's the one you want to check most frequently, or most often, is that one, the limit switch. And then once you put the fan back on, that limit switch should then make contact again. So in other words, when the fan comes on, when you put the fan back on, it should cool that switch down, and that switch should then, the bridge should come back together, the contact bit should be made, and you should the furnace should come on again. The gas fire it back up and watch it cycle. And then you always want to see a system cycle off, so that when the gas has been satisfied at the thermostat's been satisfied, the system should be shutting down. I've seen situations where the burner just keeps going sometimes, just for whatever reason, and there's like this big delay, and then eventually it just shuts off. Like, okay, there's no fan, but the burner keeps going, and a lot of times these things go undiagnosed. One of the things you'll find is that limit switches go off and on, off and on, off and on. That's usually an indication that your heat exchanger is getting too hot. So what happens is the furnace comes on, and then the fan comes on, and then all of a sudden the burner drops out, but the fan keeps running because the unit got so hot that it limited out. It took out the gas, so the gas burner dropped out. But the fan keeps running because the fan's supposed to keep running because it's hot in there, right? So fans typically they're operated usually by temperature, but oftentimes they're operated by time. More often than not now, I think they're by time on the boards.
They're by both.
Sorry?
They're by both. On the
They're by
tabs.
both on a lot of systems, time and temperature.
Yes. There's a settable delay on the newer furnaces. Some of the older ones didn't have it. And you can set 90, 120, 240, how many seconds you want that blower running after burner cut out.
Right.
And the industry standard is that fan needs to run long enough for the discharge air temperature to be 90 degrees or less
Yeah.
before that blower kicks off.
Right, and so what we're trying to do is maximize efficiency, so there's settings on the board that we can check for that. To cycle that fan off, or if it's shutting off prematurely. But if you get a situation where you have a fan cycling on and off like that, rather the burner cycling on and off, and the fan continuously running, that's one of two things. It's either a bad limit switch, or you got not enough airflow. So oftentimes that's the case, is the airflow is the issue really. So you want to check your temperatures and see what's going on. You don't want to just run out and grab another limit switch, because limit switch could be telling you something that's going on with the system. So
Kevin, it could also be overfiring.
yeah,
Because I can promise you, half of us aren't checking the supply outputs and clocking the BTUs at the gas meter.
yeah.
If it's 5,000 BTUs over what its rating is, it needs to be adjusted.
So that's a good point. So there's an adjustment on the gas valve, and you can tell, like there's just a little screw, a little tap on top of the gas valve, and you can actually adjust the flow or volume going through the gas valve. And the reason they're adjustable is because gas pressures coming in oftentimes are different. You have a regulator on that gas valve that regulates the gas coming in, but you also need to adjust the temperature accordingly. And there's guidelines on the furnace, usually labeled on the furnace somewhere, that will tell you what the range your discharge temperature should be based on your incoming temperatures.
So if the output is not correct and we are required to make the adjustment for the homeowner, is that something we do without extra charges?
It depends. You can always charge for something you do. It's one of those where, adjusting the screw on something, I may charge for that, I may not. It just depends on the circumstances. If I do charge something, it ain't gonna be much. But when I see a situation like that, that's another reason to take a close look at the heat exchanger. Because you've been overheating an appliance for a bit, however long that furnace has been in. I can assure you, if it was doing that now, it was doing it 10 years ago, and the damage has probably been done at this point. So those are the kinds of indicators that you kind of want to look for. One of the other things I look for is I want to check my vent. I want to check my induced draft motor. I want to see physically, visually, look at the vent to see if it's been compromised in any way, shape, or form. I've seen separations in attics where it's just been blowing combustion, products of combustion into the attic for some time. And there's a separation in the dual, they're just 2 inches apart or something in the attic. And there's no way you would ever know that unless you physically saw it, because you can't really diagnose it from where you're at. So a lot of times that's an attic crawl if it's not in the attic, but you basically want to kind of look at that vent and make sure that it is intact. One of the other things I want to do is take a look at the roof and see if I got a rain cap on my vent. That's another important item because those blow off. Rain gets in them, comes down into your unit, creates all kinds of havoc on your induced draft motor. So it's really critical that you take a close look at the vent as well. Most furnaces today, if you got a gravity furnace, then you probably need to replace that. But especially with a gravity furnace, even when I'm putting in water heater. A water heater is a gravity furnace. It does not have a motor typically for induced draft. So it's the draft is going by gravity. So that little that little dome-shaped hood that goes on top of the water heater that we were wrestling with yesterday. I always take a match, and when the burner's on, and I put light a match, and I put it there. If it blows out the match, no bueno. There's a problem with your vent, right? So you got to fix that. But yeah, so I always. It's kind of a safety check on, and you could do that on a furnace too that's gravity fed, but if you're running into a gravity fed furnace, it's a phone call to management. Because there's significant liability in touching a furnace that old and putting our stamp of approval on something that should have been replaced 10 years ago, at least, so. And I don't mess around with stuff like this, Like I ran into this 2 horizontal gravity fed furnaces in an attic with all bad ductwork in San Clemente, and elderly couple, and he basically, hey, could you do me a tune-up? And I said, I'll do a safety inspection before I do anything. I already noticed that there was a problem with one of his furnaces something was apparent. It smelled gas or something like that coming out of the gas valve. And they start to leak after a period of time. But this was at least a 30-year-old furnace. And horizontal in an attic and everything original. And all the gray ductwork that was peeling apart, defective ductwork. And he goes, well, I'm going to sell the house. And I don't want to replace anything. And I said, well, all right. I said, but, first thing they're going to do is inspect this system. You're going to at least have to do the ductwork. They're going to call you out on that. Well, he never bid on that, but the point is that I told him that I will do a safety inspection, and I told him, I said, there's a good chance those furnaces will not pass the safety inspection. I'm just letting you know. They're an old appliance, and they should have been replaced 10 years ago. And so he declined to have it done because he just wants to get past the problem on to the next guy.
Was it that elderly couple?
Yeah.
Wow.
He never, I called him back, I did a follow-up and nothing. So he doesn't want to deal with the issue. They're selling their house in a year. And he's probably got, $1.5 million in equity on that property at least. Because it's one of the gated communities right next to Vanguard's. And he came in there 30 years ago and bought this house, so, and they were dirt cheap then.
I'd say more in equity.
Oh yeah, at least $1.5 million I'd be, but yeah. So it's not like, it's like, and the house is twice as big as what they need. I mean, cause it's 2 3-ton furnaces, so it's over 4,000 square feet. And they barely make it up the stairs already, so it's kind of like, really?
Quite a few of the houses we work in are quite opulent.
Yeah.
There's no need or wanton for, a state like Paul Mirage, but
Yeah.
I mean,
No,
yet
it's
here we are.
A lot like that.
Yeah, well, my point is that really, I mean, you've got all this equity, right, in this house, and you're gonna live with this dangerous thing in your attic, that's lighting fires, and you're gonna continue to use it. And I said, no, I told him, I said, if I touch those furnaces, you probably won't have heating today. Because I'm gonna turn them off. I'm
I told my parents that a few weeks ago.
Yeah?
Yeah, I bumped into them a few days ago, and they're like, "Yeah, it's getting really cold." I was like, "Yeah, you should get a new furnace." I know a guy. They're like,
I know a
do
guy.
you think you can turn it on just a little bit? No, I'm not going to poison you now that I've seen it. I'm not going to let that happen.
Yeah.
Okay.
You're a great
Well,
How much, Ryan?
well,
You're gonna fix
all right.
this.
Well, I just recommend you guys, get some blankets.
Yeah. It's the funniest thing
Either you can
because
get a furnace or get some blankets.
Hey
Yeah.
Ryan, how much are you gonna charge him?
I know.
How much am I going to charge them?
Yeah,
That's between me and my parents.
'cause I'll beat it by $1,000.
so anyway, yeah, it's kind of a funny thing, but people are, I don't know, for whatever reason, and that's why I like to talk to you guys all the time about calling these things appliances, because that's what they are. But people like to hang on to them. I mean, the same people will not drive on tires that are bald, absolutely not. Yet, they're perfectly fine with a 30, 40-year-old appliance starting to fire in their attic. They just don't care. And it's so bizarre to me. But it's a communication issue, obviously, because this makes sense to replace this. Go
I
ahead.
feel like it's because it's not something that typically in a lifetime people are going to be doing on multiple occasions. Not an average person, they're going to be replacing their furnace. It's not something that they're going to do 2 or 3 times in their life, not the average person.
I think there's some truth to that. I think they're, it's a $10,000 proposition,
Big
and
investment.
not everybody's, willing to go there. And that's where you got to kind of explain to them that, the cost of operation. It's like an old car. I often say, you're going to start spending money on repairs,
I
yada,
know
yada,
you got a brand
yada.
new Lexus. Are you really that afraid right now?
Yeah, and so, it's at some point you're going to have to replace this, anyway. You might as well do it now and get some enjoyment and some usage out of it.
It's more of a cosmetic thing, though, because people like to renovate their homes, but they don't care about the plumbing.
Oh yeah, they don't
the
care
air
about what's
conditioning.
underneath.
Because
If they
Yeah.
can't see it, they don't care.
Yeah.
That's all that
They
matters.
do
As long as it
aesthetics.
looks pretty,
They
they're
don't
good with
do,
it, yeah.
like-
The second that
Yeah.
pipe breaks or that heater doesn't work or the AC doesn't work, now it's a problem. But
Yeah.
until
Or
then,
your
they don't
home is
see
on
any reason why to invest money into something they don't have in their hands.
Yeah.
Especially
Right.
when you see
That's the age
$1,000
we live in.
furniture in their home, but they won't buy a furnace. You're like, that couch is a furnace right there. You got a $10,000 couch. That's a furnace. You could have bought a furnace instead of
Yeah.
a couch.
But their friends won't see it, so that's
The problem
nice.
is that their homes will most likely lose value with, an air system that's like that.
Yeah,
It's
I mean,
not like
so-
appraisers won't come in and check all of that.
Yeah, so I had recently I did an inspection where the furnace was non-op, and they had a previous company, Capital Air, went out there and said you needed a whole new system, and the house was up for sale. And so that was the report that the buyer got. So I was out there for a second opinion. And I just basically said, yeah, you have an original system, it's in good working condition, which it was, shockingly, but it wasn't that old, it was 20 maybe. I said, but it's 20 years old. And the guy who wanted to buy the house called me up, and he's asking me all these questions, about, well, can't you just say that it needs to be replaced? And I go, well, yeah, I can say that, but legally, that's all that matters is it working? For purposes of getting a loan and everything else, you gotta make sure you have operational air, operational heat. And I said, and we did that. Because one of it was just a loose wire, and the other one was a little bit of refrigerant. And the systems, of course, they need to be replaced. They're in bad condition. They're close to the ocean. Those condensers are toast, but they're working. It's cooling. Everything passed inspection, okay? I said, but the owner wound up having to credit the guy $5,000 toward replacement of the system, which is probably gonna run him about 20 G, but there's some stuff coming our way, by the way, in this industry that's gonna change all of this opposition to replacing people's equipment. And that is that homes will be appraised based on their R value. So their R value. So R
Insulation.
value is the insulative factor of something. So on a water heater, you have an R value of 16 or 18 or 19 on the water heaters that we install because they're in garages, so they have to have extra R value. You know, the R value of the ductwork, is it R8 or is it R6, right?
Oh.
Yeah, so that R value is important. Well, now they're looking at the home and the envelope, what they call the envelope. And the envelope is your roof, your attic, your doors, your windows, all the things where energy is lost, you know, basically. Or heat gain takes place, or loss of heat, or whatever. So what they're going to be doing, the way they appraise homes now is they do what's called comps. And they say, well, what did the last 3 homes in your neighborhood sell for that are similar to yours?
Oh, yeah.
And that's how they value your house. And then they edit it. They edit that value based on, you know, do you have a swimming pool? Do you have a deck? Do you have this? Do you have that? And they give you credit for this and that, right? Well, what's going to be happening is they're going to be appraising the home, and included in that appraisal is going to be the home's energy efficiency. Because you could have a house right next door to each other, positioned the same way in the sun and everything else, exactly the same model, and one's bill will be $200 more a month than the others. Because, you know, of the energy efficiency. Now, if you take that $200 a month, you multiply it by 12, and then you multiply that by 30 years, that's a big difference in price. So,
And you had inflation, so you had an extra.
right, exactly, and plus the cost of energy is not fixed,
Right.
right? It's not static. It keeps going, and it keeps going in one direction,
And it only goes
right?
up.
So it only goes up. It only
We're
costs
never
more.
gonna make energy less
Yeah.
expensive.
Yeah, gas is not cheaper than it used to be. You know, electricity is more than it used to be, and it's going up for everything, right? So that is coming our way to where when that happens, when the homes, and I'm surprised California hasn't done it yet, but they will be soon. But when they have a methodology for that, you can bet that people will be looking differently at how the HVAC system. They're not going to necessarily be going for the cheapest one. You know, I don't need all that efficiency. You know,
They're gonna be
really,
forced to look at
because it's going to cost you when you go to sell your house. And here's why. So people are going to be cleaning up in the attic. They're going to be insulating. They're going to be getting high efficiency equipment. They're going to be doing all of those things. You know, I cut my energy bill significantly just by putting in a 25 SEER and a variable speed furnace. I mean, it just blows me away. I run that thing all the time. My bill's next to nothing. Yep.
The people, are they certain companies that do inspections only for like before they sell the houses, or is it just they can find any plumber or any?
That's a good question. So those inspectors they're very generalized inspections. So in other words, they visually see that the duct's falling apart, and they go, your duct's falling apart. But they couldn't tell you if that duct's sized properly or not. They have no idea, none.
Yeah, but do they have like a special certification?
Yeah, the home
They do?
inspectors do, yeah.
Yeah,
Oh,
it's a home inspection certificate.
Because you're
Yeah.
saying how the industry's changing, well, we're gonna have to evolve with it too, so.
Right. Well, the home inspectors, though, you have to realize that, you know, it's all this I don't know what you want to call it, but it's kind of, the best way I could describe it is they have misplaced loyalties. So a realtor will hire an inspector to come in and look at the home, and they really don't want you to emphasize a lot of the issues. Just say, whatever's obvious, just note that. Let's not get ridiculous here, I want to sell this house, because their commission's tied to the sale, right?
Yeah,
So the realtor wants to get in, get out.
so,
You know,
so that's why it's a general inspector
Close that,
then, right?
yeah. So I can tell you, when you're buying a house, typically the sewer it never gets cambered, never, right? But it's probably, there's $10,000, $20,000 problem underground that you don't know nothing about. But you buy a house not knowing that you just bought something that's gonna cost you 10, 20 grand in a few years, right? It's just in a house last week. The guy had asbestos. He bought the house 3 months ago. Nobody told him.
Damn.
He's got all asbestos ductwork, you know? I said, it probably was disclosed. And he goes, no, I don't think so. I said, probably was disclosed. And and they just didn't highlight it. You know, hey, they didn't put a shining red light, you know, flashing red light saying you got asbestos in the attic. You know, they didn't.
They just
you
gave me
know.
the paperwork and said, so this is what we found.
Yeah.
Go ahead, sign the bottom.
Yeah, it's one of those long agreements like you get when you're online. Do I agree? Yeah. You know, you didn't read that 20-page legal document. Nobody
Terms and
does.
conditions.
Nobody
Yeah,
does.
exactly. So the guy now has a house full of asbestos. He's like, oh shit, I didn't know. You know.
Yeah, there's,
Just burn a house.
you'll wind up going on calls, cause I've gone on, I think about 4 of them, after home inspectors have condemned a unit saying that it needs to be replaced because it didn't have a 20-degree split.
Mhm.
Well, how do you guys measure a temperature split?
Not sure.
With a thermometer.
What kind of thermometer?
What kind would I use?
You mean a psychrometer
Sure.
that measures your humidity and your temperature?
Yeah.
Because that's the only way you're gonna determine what that temperature split has to be.
Mhm.
If you take your little laser infrared thing and point it at the vent, you're never gonna have a 20-degree split, ever, unless the system has the wrong airflow.
So you need a hypomom. What did you say it again, please?
Psychrometer.
Psychrometer.
That
And-
weird,
That's that
that
one
weird
that-
little pen thing that I have.
That's what I
that-
need.
It's a $45 item
You
that
said that one
will,
house, right?
Yeah.
Okay.
and I have made quite a few home inspectors look really stupid in front of the homeowner.
Yeah. But these guys, they have a general idea of what they're looking at. That's all they have.
Right, basic.
Very
The
basic
handyman.
understanding,
Yeah.
and
Yeah.
they really
Yeah.
don't. They don't understand the science of it. So,
So
you know,
just
so
take the
people.
time and explain it to them.
So people really, you know, the whole idea behind a house inspection is so the homeowner is making an informed decision. Well, guess what? They're not. You know, just 99% of the time they are not making an informed decision.
I gotta go to the bathroom.
So anyway, but yeah, and home inspectors are, you know, they're just doing their job. They you know, they're just going through the checklist, the obvious stuff, and you know, I don't put much stock into those. If I was buying a house, I would probably hire a plumber, hire an HVAC guy, hire an electrician, you know, to go through the system and have an expert look at the system.
So it'd be a good idea, like, maybe for one of us, or to have a in-house kind of guide for the down seasons, right? To have a guy that knows or learns inspection, or no? Whatever.
Well, that's what we're training on. So these tune-ups are basically inspections. They're inspections of your furnace and air conditioning system. That's why we're in the house 2 days out of the year. You know, we go once before heating, once before cooling, and we check it out.
You're talking about when you go in with the hopper, right? With the hopper, the little spray?
Yeah,
Yeah,
exactly. The
That's-
spray
that's the-
hopper.
that's the inspection, right?
That's a safety inspection. We're checking a device,
Oh.
a portion of the heat exchanger. We're not checking the whole furnace, but that's a part of it.
Okay.
So, you know, we're going through the entire system. We wanna look at everything, ductwork, vent, you know, everything on that sucker. You know, I look at the outlets, you know, when's the last time that was replaced? Cause you get furnaces replaced, but they don't replace the damn outlet. You know, how long does an outlet last? They've
Marie
replaced
Lynch.
all of them in the house, right?
Marie LaChance,
Yeah, exactly, there you go.
case in point.
Case in point. Yeah, we were chasing our tails in this one house where we installed the system.
From the minute that system was put in.
From the minute it was put in, there was a bad outlet, and it was affecting, it was giving us callbacks all the time. We get there, everything's running fine, you know, it was just this nonsense. And then we found out, oh, bad outlet.
And it left the customer with a very bad.
Yeah.
Bad
Oh,
look
wow.
at us, and,
Well, it's an intermittent problem. It's not there all the time. But the point is that these are the little items that, hey, you know, I noticed this is the original outlet. I know you don't have original outlets in your house anymore, but this one got missed. We should replace it, especially since this is an appliance. It's a 20 amp. It pulls a lot of electricity through it. It's a dedicated circuit. It should have a new outlet. You can sell those for $160, $180, something like that. Just boom.
and,
Pick up your ticket right there.
speaking on outlets, as a lot of you know, we have to sell what's called an ECM motor now. We can't sell a split capacitor motor for installs anymore.
Oh,
The ECM motor drive is an inverter, so it takes AC power and converts it to DC power, and then chops it up again to make the motor run at whatever speed it wants it to. If you have dirty power going into that, that module's gonna die. And that's exactly what happened at Maria LaChance. The power was dirty going into it because it was intermittently disconnecting, and it fried the inverter board to where it wouldn't work on low speeds. It would only work on a higher speed call.
Oh, wow.
And truth be told, price differences between the two motors is about 3 times. So a PSC motor is much cheaper, but it's a lot less efficient. So now here we are, having to put in ECM motors. So it's even more important that you understand how to check the power and make sure that everything is what it's supposed to be. The inverter board causes a 40% overage on voltage. So if you got 100 volts coming in, it's 140 volts DC going out. So the variations in voltage are much more exaggerated when it comes to an ECM motor, and that's what causes it to die.
Yeah. So case in point, there is a good example. You see an old outlet, just, recommend replacement. I mean, we're doing all these code upgrades, that matter. Yes, they matter, safety switches and drip legs and things like that are important, for the preservation of the system. We're trying to protect the system. But that outlet, man, 9 times out of 10, I look at those and I'm like, dang, that's original, and they're cracked and chewed up and loose in the box, and and it's like, yowza, and it's not, electricals. It's, at the end of the day, that's where your source is. Everything's running off of that. And case in point, there was a system that got replaced on a rooftop, probably $12,000, $13,000, $14,000 system put on a roof, and it had dirty power. And my repair was somewhere around $8,000 on a 1-2-year-old system. $8,000, right? And it was because of the breaker. It wasn't even the disconnect box. It was the breaker that was bad. So that was feeding it. So it's not just changing the outlet. You got to check. You got to check your power source on these things. As appliances become more and more evolved, efficiency-wise and everything else, when you start having failures like that, you better check your power. And it could be intermittent too. And what happens, by the way, flow of electrons, what happens when there's a restriction? Anybody?
Heat.
Yeah, things get hot. And what happens when things get hot?
They melt.
They expand. Anything that gets hot is typically going to expand, just like water at thermal expansion, right? So it expands. So you've got a breaker that clips on. You've seen how sloppy these things clip on, and how loose they could be, almost fall off out of board on your hand, when you touch them. So that connection, there's that, you got that little device, and you kind of clip your breaker, and it kind of, it's a male to a female kind of thing, and it slides in there. Well, just like an outlet that's loose, so can a breaker be loose. Have you ever plug into an outlet and the damn plug falls out? Well, guess what? You need a new outlet. So I'm just saying. I got one in my house I've been meaning to do, and it's just like, damn it. I go to charge my phone, and the damn thing falls out from the weight of the charger, right?
Stupid charger.
They make outlets that have USB ports now, Kevin.
Right, I know that. Which is what it's gonna get, by the way. 'Cause I'm tired of chasing that stuff. But the point is that, those are the types of things that can be going on. And yes, we are not electricians, but these are things we should know. Because we're not gonna call an electrician when we're replacing a furnace to replace the outlet or the breaker. We're gonna do that ourselves. It's
Well,
easy enough.
Our C20 license allows us to do certain things that are electrical.
Yeah.
From my understanding.
Yeah, we
now-
can do electrical,
From
some of it.
From my understanding, we can do everything but go in the box.
Mm.
I mean, we all know that the trade does it.
Yeah.
We're gonna hook up our own breaker. We're not gonna call a guy.
Plumbers aren't supposed to touch the water meter either.
Yeah.
I'm like, Yeah, we're just gonna call the water company and wait.
We all know
Yeah.
what we all know we pull our own wires, even though we're supposed to have somebody else pull our own wire for an ad area.
Yeah,
Because
no.
the way it's all worded for contracting is you're allowed to do anything that's limited to your trade, and unfortunately, an ad area is part of our trade.
We went really long, I'm
Yeah.
sorry.
Yeah.
Real quick though, on the
Yeah.
outlets,
Uh-huh.
is it changing for 2020 on the GFI requirement?
I don't know to that.
I know attics were required to put in the GFI on a new install, like if we relocate
Okay.
or if we replace an outlet.
Mhm.
I don't know if they changed it for closets or not,
Yeah, I
Like
don't know.
but
I
we
don't
should be
know.
putting in an arc fault GFI.
Yeah.
Anyway, if you're replacing an outlet.
Yeah.
Yeah.
And, you know, to that point, we should start stocking them on our trucks. You know, I mean, what is it, a $20 part if that? A good GFI?
Good GFI is about 24 at the worst
Yeah,
from Leviton. So
yeah. $180 easy. Easy.
It's not uncommon that they blow.
Yeah, and that's 180 plus whatever else you're doing that day. You know, that's why all the stuff that I do, it's 150, 180, 160. You know, it all adds up. Next thing you know, $900. Yeah. You know, but you know, and it's $900 all done within an hour typically. You know, or an hour and a half or stuff like that. You know, so it's not. You think, oh, it's not going to add up, but it does. It adds up pretty quickly at the end of the day. You know, and if you get a couple $1,000s in labor at the end of the day, yahoo! Because you're probably getting 32% of that as a technician. It's probably somewhere around there. You know.
if you're making your goal, yeah.
Yeah, and you're hitting your numbers, and it's just these little things that are so simple, you know, that, you know, if you just notice them, that, you know, I always looked at my average ticket when I was a service tech, and my average ticket used to be probably around $1,200-$1,300 average ticket. So that means on every job I went to, I was pretty much getting $1,200-$1,300 on those, and that included inspections as well. Especially inspections, because when you're doing a whole house inspection, man, it's just, you look at everything.
Yeah.
Okay. That's why I'm
Kiros
here.
residence is a prime example of that.
Yeah.
That upstairs heat pump.
Huh? So yeah, it's just you're always going to find something, always. You know, this is why we're in the house 3 times a year. This is why we do the inspections. So anyway, that's it. Any questions before we leave? Nope. All right. We'll be